So we're going to look at increasing and decreasing intervals of a function. This is our introduction to finding maximums and everything. When we start now to get rid of the closed intervals and we look at the entire domain, negative infinity to infinity. So in order to figure out your increasing and decreasing intervals, the first thing you need to start with is you need all critical numbers. So we got to find the critical numbers. When we find the critical numbers, we've done this now, we go f prime of x equals 2x plus 2 and set it equal to 0, and I get 2x plus 2. Solve that and I get x equals negative 1. So this is the critical number on the interval. So let's now draw that on a simple number line, negative 1. Now this is a number line for f prime of x. Okay, and let's keep in mind that f prime of x, that doesn't look too good. F prime of x represents the slope. So slope positive means it's going up. Slope negative means it's going down. So if we pick values around this negative 1, we can test to see if the slope is positive or negative. So what I mean by that is let's pick some easy test values. So negative 2 is on this side of negative 1 and 0 is on this side. When I take this negative 2 and I plug it back into f prime of negative 2 equals 2 times negative 2 plus 2, which is negative 4 plus 2, which is negative 2, but really all I care about is the fact that it's negative, meaning if the slope is negative here, it is decreasing. And I'll signify it on my chart just like that. The slope is decreasing. Now when I go f prime of 0, so now I'm plugging in 0 into the derivative to figure out what is the slope at 0. So I get 2 times 0 plus 2 is equal to 2. Again, it's 2, but I'm really interested in the fact that it's positive. So it then goes up. And that means at negative 1 we have a minimum because it went from decreasing to increasing. So when I go and write out my intervals, increasing, negative 1 to infinity, decreasing, negative infinity to negative 1, and I have a max or min. I said I have a minimum at negative 1 comma what? Well, I got to take negative 1, and it's a minimum on the original function. So we got to plug it all the way back in here and here. So I get, when I plug in negative 1, I get 1 minus 2 minus 3, so I get negative 4. So by taking the derivative, I can figure out what the critical numbers are where the slope is equal to 0. I then take that and I put that value on a number line, so negative 1, and then I choose values around it. So these are test values. This test value tells me the sign of the slope everywhere on this interval. If it were to change anywhere else, I would have more critical numbers. So I guarantee that it will decrease all the way to negative 1. And when it gets to negative 1, we found with the test value of 0 that it increases to infinity. And guess what, folks? Let's go back and analyze our initial function. It was quadratic. Even, positive leading coefficient, we know it opens up, so it should take on that parabolic shape.